Right now, as you're watching this video, you're hurtling through space at over 500,000 miles per hour. You can't feel it, you can't sense it, but every atom in your body, every breath you take, every thought crossing your mind is being dragged along by something so massive, so incomprehensibly powerful, that it defies every instinct we have about the nature of reality itself. 26,000 light-years away, hidden behind veils of cosmic dust and gas, lurks a monster. Not the kind from your childhood nightmares, but something far more terrifying because it's absolutely real. This creature has no teeth, no claws, no roaring voice that echoes through the darkness. Instead, it devours light itself, bends the very fabric of space and time, and holds our entire galaxy in its gravitational grip, like a cosmic puppet master pulling invisible strings. This is Sagittarius A star, and it's about to challenge everything you think you know about the universe. But here's what makes this story truly extraordinary. For most of human history, we had no idea this monster existed. We looked up at the night sky, saw the gentle sweep of the Milky Way across the darkness, and assumed we understood our cosmic neighborhood. We were wrong. Catastrophically, beautifully wrong. In this video, I'm going to take you on a journey to the very heart of our galaxy, where the laws of physics get twisted into impossible shapes, where time itself slows to a crawl, and where the boundary between science and science fiction dissolves entirely. We'll explore how scientists first detected this invisible beast, what happens when you get too close to its edge, and why understanding Sagittarius A star might be the key to understanding our place in an infinite cosmos that's stranger than we ever dared imagine. If you find comfort in these gentle explorations of space and science, I'd be grateful if you'd consider subscribing and giving this video a like. I'd love to know where you're watching from and what time it is for you. Feel free to drop your location and time in the comments below. By any chance, if your curiosity stretches beyond space and science, I would love to invite you all to visit and take a look at our new channel, Boring Money. A place where finance slows down and fortune gently drifts in. I've dropped a link in the video description. Do consider checking it out. But before we dive into the abyss, let me share something that will blow your mind. The monster we're about to meet isn't just massive. It weighs 4 million times more than our sun. That's not a typo. 4 million suns, compressed into a region smaller than our solar system. And yet, despite its unimaginable mass, despite the fact that it's literally holding hundreds of billions of stars in orbital submission, this thing is so dark, so perfectly black, that we've only recently managed to take its photograph. The first image of Sagittarius A star was released just 2 years ago, in 2022, and what it revealed changed astronomy forever. You see, this isn't just another space documentary about distant objects that have no impact on your daily life. This is personal. Right now, as you sit there, Sagittarius A star is determining your fate. It's the reason our solar system exists in this particular corner of the galaxy. It's the reason the seasons change the way they do. It's even influencing the cosmic radiation that shapes evolution on Earth. We are, in the most literal sense, children of this monster. The story of how we discovered Sagittarius A star reads like a cosmic detective novel, filled with brilliant minds chasing invisible clues across decades of painstaking observation. It begins in the 1930s, when a young engineer working for Bell Telephone Laboratories accidentally stumbled upon radio waves coming from the center of our galaxy. He had no idea what he was detecting, but he had just heard the first whisper from the monster's lair. For the next 50 years, astronomers would piece together fragments of evidence like investigators working a cold case. They couldn't see their target directly because it's hidden behind thick clouds of interstellar dust that block visible light. But they could detect its influence. Stars near the galactic center were moving in ways that defied explanation, whipping around invisible gravitational anchors at speeds that should have torn them apart. Then came the breakthrough that changed everything. In the 1990s, two teams of astronomers began tracking individual stars orbiting near the galactic center with unprecedented precision. What they discovered was so extraordinary that it earned them the Nobel Prize in Physics. These stars weren't just moving fast, they were moving impossibly fast, completing orbits that took them closer to the galactic center than Pluto is to our Sun, reaching speeds of over 15 million miles per hour. One star in particular, designated S2, became the smoking gun that confirmed the monster's existence. S2 completes a full orbit around Sagittarius A star every 16 years, and when it reaches its closest approach, something remarkable happens. The star's light gets stretched and distorted by the extreme gravity, confirming Einstein's predictions about how space and time behave near massive objects. This wasn't just astronomy anymore. This was physics at its absolute limit, where theory meets reality in the most extreme environment imaginable. But here's where the story gets truly mind-bending. The object these stars are orbiting, this 4 million solar mass monster, occupies a region of space no larger than about 20 million kilometers across. For comparison, that's smaller than the orbit of Mercury around our Sun. How do you pack that much mass into such a small space? There's only one answer that makes sense, and it's an answer that would have sounded like pure fantasy just a century ago. Sagittarius A star is a supermassive black hole. Not just any black hole, but our black hole. The gravitational anchor point around which our entire galaxy rotates. And when I say entire galaxy, I mean every single one of the estimated 400 billion stars in the Milky Way, including our Sun, are ultimately dancing to the gravitational rhythm set by this cosmic monster. Now, before we go any further, I need to address something that might be making you uncomfortable right now. When most people hear black hole, they imagine a cosmic vacuum cleaner that's going to eventually suck up everything in the universe. That's not how black holes work, and Sagittarius A star isn't going to destroy Earth or even our solar system. We're far too distant to be in any immediate danger, but that doesn't make it any less fascinating or important to understand. The real question isn't whether Sagittarius A star will destroy us. The real question is how this monster shaped the very existence of everything we know and love. You see, supermassive black holes like Sagittarius A star aren't just cosmic curiosities sitting at the centers of galaxies. They're the architects of cosmic structure itself. They determine how galaxies form, how they evolve, and how they die. The relationship between Sagittarius A star and the Milky Way is one of the most beautiful examples of cosmic symbiosis in the universe. The black hole's gravity holds the galaxy together, preventing it from flying apart as it rotates. But the galaxy, in turn, feeds the black hole, sending streams of gas and dust spiraling inward in a process that releases more energy than billions of nuclear bombs every single second. This feeding process creates one of the most spectacular light shows in the universe. As matter falls toward Sagittarius A star, it forms what astronomers call an accretion disk, a swirling maelstrom of superheated gas that glows brighter than entire star systems. The friction in this disk heats the gas to temperatures of millions of degrees, causing it to emit radiation across the entire electromagnetic spectrum. From radio waves to X-rays, Sagittarius A star broadcasts its presence across the galaxy like a cosmic lighthouse. But here's what makes this truly extraordinary. The monster at the heart of our galaxy isn't always hungry. Sometimes it goes quiet for years, decades, even centuries, barely consuming any matter at all. Then, without warning, it roars back to life as a new stream of gas or an unlucky star wanders too close to its gravitational web. These feeding frenzies can increase the black hole's brightness by factors of hundreds or thousands, turning our normally quiet galactic center into a blazing beacon visible across intergalactic distances. The most recent major feeding event happened just a few years ago, when astronomers watched a cloud of gas called G2 approach Sagittarius A star. For months, they held their breath, waiting to see if the cloud would survive its close encounter or be torn apart and devoured. The cloud survived, but barely, emerging as a stretched and distorted shadow of its former self. It was like watching a cosmic near-death experience in real time. This brings us to one of the most mind-bending aspects of studying Sagittarius A star. Because of the extreme gravity near the black hole, time itself behaves differently. If you could somehow survive near the event horizon, the boundary beyond which nothing can escape, you would watch the rest of the universe age rapidly while your own time crawled forward at a snail's pace. This isn't science fiction. This is Einstein's general relativity playing out in the most extreme gravitational environment in our galaxy. The stars orbiting closest to Sagittarius A star experience this time dilation effect, though to a much smaller degree. When S2 reaches its closest approach to the black hole, time passes about 200 seconds slower for every million seconds that pass for us here on Earth. It's a tiny effect, but it's measurable, and it confirms that our understanding of gravity and space-time is correct even in these extreme conditions. But perhaps the most remarkable thing about Sagittarius A star isn't what it does to space and time. It's what it reveals about the history of our galaxy and our place within it. You see, supermassive black holes like this one don't just appear overnight. They grow slowly over billions of years, accumulating mass from their surroundings and occasionally merging with other black holes when galaxies collide. The monster at our galactic center has been growing for nearly as long as the Milky Way has existed. It was already ancient when our solar system formed 4.6 billion years ago. It watched the birth and death of countless generations of stars. It witnessed the formation of the heavy elements that would eventually become planets, and life and consciousness capable of contemplating its existence. In a very real sense, Sagittarius A star is the reason we exist. Without its gravitational influence, the Milky Way would never have developed the stable spiral structure that allowed regions like our local galactic neighborhood to remain relatively calm and safe for billions of years. The ordered rotation of our galaxy, the way spiral arms sweep through space distributing heavy elements and triggering star formation, all of this cosmic choreography is orchestrated by the monster at our galactic center. But the story of Sagittarius A star is far from over. In fact, we're living through one of the most exciting chapters in its history. Right now, astronomers around the world are watching and waiting for something extraordinary to happen. You see, our galactic neighbor, the Andromeda Galaxy, is heading straight for us at 250,000 miles per hour. In about 4.5 billion years, Andromeda will collide with the Milky Way in what astronomers poetically call the Andromegalactic collision. When that happens, Sagittarius A star won't be alone anymore. It will meet Andromeda's own supermassive black hole, an even larger monster weighing in at over 100 million solar masses. These two titans will spiral toward each other in a cosmic death dance that will reshape both galaxies entirely. But don't start planning your escape route just yet. The collision won't be like two cars crashing head-on. Space is so vast and stars are so far apart that most individual star systems, including our own, will likely survive the merger unscathed. What will change is the very structure of our cosmic home. The orderly spiral arms of both galaxies will be scrambled into a new formation, probably an elliptical galaxy that astronomers have already nicknamed Milkomeda. The real fireworks will happen when the two supermassive black holes finally merge. This event will release more energy in gravitational waves than all the stars in both galaxies combined produce in light. The ripples in space-time will be so powerful that they'll be detectable by gravitational wave observatories across the universe. It will be the loudest cosmic event in the local group of galaxies, a merger that announces the birth of a new galactic empire ruled by a single, even more massive black hole. This brings us to one of the most profound questions in modern astronomy. How did supermassive black holes like Sagittarius A star get so big in the first place? You might think they started small and gradually grew by eating stars and gas over billions of years. But the math doesn't add up. Even if a black hole devoured matter at the maximum possible rate, it couldn't grow from stellar size to millions of solar masses in the time available since the Big Bang. The answer appears to be that supermassive black holes formed through a completely different process than their smaller cousins. Instead of being born from the collapse of individual stars, they may have emerged directly from the primordial universe itself. In the cosmic dark ages, before the first stars had even formed, massive clouds of hydrogen gas might have collapsed directly into black holes without ever becoming stars at all. These primordial monsters would have been the seeds of cosmic structure, the gravitational anchors around which the first galaxies began to form. They grew rapidly by consuming the abundant gas of the early universe, reaching enormous sizes while the cosmos was still young and dense. Sagittarius A star isn't just the heart of our galaxy. It's potentially one of the oldest objects in the universe, a relic from an era when the fundamental forces of nature were still shaping the cosmic landscape. This realization has profound implications for how we understand our place in the universe. We're not just living in a galaxy that happens to have a black hole at its center. We're living in a galaxy that exists because of that black hole. The monster shaped the very environment that allowed stars like our sun to form in stable, long-lived orbits. It created the conditions necessary for planetary systems to develop and persist for billions of years. But Sagittarius A star's influence extends far beyond mere gravitational architecture. The black hole acts as a cosmic thermostat, regulating the temperature and density of gas throughout the galaxy. When it feeds actively, the energy it releases heats up the surrounding gas, preventing it from cooling and collapsing to form new stars. When it goes quiet, star formation can resume in nearby regions. This feedback mechanism means that Sagittarius A star has been controlling the birth rate of stars in our galaxy for billions of years. It determines not just where stars form, but when they form and how many form at any given time. The monster doesn't just hold our galaxy together. It actively manages its evolution like a cosmic ecosystem engineer. Recent observations have revealed that this management system is incredibly sophisticated. Sagittarius A star doesn't just randomly consume matter and release energy. It responds to the conditions in its environment, becoming more active when there's abundant fuel available and going dormant when resources are scarce. It's almost as if the black hole is alive, breathing in rhythm with the galaxy around it. The breathing pattern of our galactic monster follows cycles that last millions of years. During active phases, Sagittarius A star blazes with the light of billions of suns, heating gas clouds throughout the inner galaxy and launching powerful jets of particles that extend thousands of light years into space. These jets carve enormous bubbles in the galactic gas, creating structures so large they dwarf entire star-forming regions. During quiet phases, the monster becomes almost invisible, detectable only through the orbital dance of nearby stars and the occasional flicker of radiation from small amounts of infalling matter. These dormant periods allow gas to cool and accumulate near the galactic center, setting the stage for the next feeding frenzy when conditions are right. We're living through one of these quiet periods right now. Sagittarius A star is consuming matter at a rate far below its theoretical maximum, barely glowing with the energy equivalent of a few million suns. But astronomers know this tranquility won't last forever. The monster is simply waiting for its next meal, and when that meal arrives, our entire galaxy will light up like a cosmic Christmas tree. The most likely trigger for the next major feeding event will be the disruption of gas clouds by of a star that wanders too close to the point the gravitational influence of nearby stars, or the unfortunate fate of no return. When that happens, we'll witness one of the most spectacular shows in the universe, broadcast live from the heart of our own galaxy. But here's what makes studying Sagittarius A star so challenging and so fascinating. The monster is hidden behind layers of cosmic dust that block most wavelengths of light. For decades, astronomers could only glimpse it indirectly, like detectives trying to understand a crime scene through shadows on the wall. They had to develop entirely rays to peer through the cosmic fog. The breakthrough came with new ways of seeing, using radio waves, infrared radiation, and the development of adaptive optics, and space-based telescopes that could compensate for atmospheric distortion and cut through interstellar dust. Suddenly, astronomers could track individual stars as they orbited the invisible monster, mapping their paths with precision that would have been unimaginable just a few decades earlier. The most remarkable of these stellar dancers is a star called S62, which holds the record for the closest approach to Sagittarius A star ever observed. At its nearest point, S62 comes within just 120 times the distance from Earth to the Sun, traveling at nearly 5% the speed of light. For comparison, that's like a race car completing a lap around Earth in less than 7 seconds. At such extreme speeds and in such powerful gravitational fields, the very nature of reality becomes fluid. Space contracts, time dilates, and the familiar laws of physics push into regimes where quantum mechanics and general relativity must somehow work together to describe what's happening. S62 and other close orbiting stars have become natural laboratories for testing our understanding of fundamental physics in conditions that can never be replicated on Earth. Each orbit of these stellar test particles provides new data about the nature of gravity, the structure of space-time, and the behavior of matter in extreme environments. They're writing the equations of physics in their orbital paths, creating a cosmic textbook that astronomers are only just learning to read. But perhaps the most extraordinary aspect of Sagittarius A star isn't its gravitational influence or its role in galactic evolution. It's the fact that this monster, this 4 million solar mass beast that holds our entire galaxy in its grip, is actually quite small compared to the supermassive black holes found in other galaxies. In the cosmic hierarchy of monsters, our Sagittarius A star is practically a lightweight. The largest supermassive black holes in the universe dwarf our galactic monster by factors of thousands. There's a behemoth called TON 618 that weighs in at over 60 billion solar masses. That's 15,000 times more massive than Sagittarius A star. If our monster is a great white shark, then TON 618 is Godzilla with a physics degree and a bad attitude. But here's the beautiful irony. The fact that Sagittarius A star is relatively small might be exactly why we exist. You see, there's a delicate balance at play here. If our galactic monster were too small, it wouldn't be able to hold the Milky Way together. The galaxy would be a chaotic, unstable mess of stars flying in random directions. But if it were too large, it would be so active, so violently energetic, that it would sterilize vast regions of the galaxy with deadly radiation. Sagittarius A star sits right in the cosmic Goldilocks zone. Not too big, not too small, but just right for creating the stable, long-lived galaxy that allowed complex chemistry to develop over billions of years. It's as if the universe fine-tuned our monster specifically to create conditions suitable for life. This realization has led some scientists to propose what they call the galactic habitable zone theory. Just as planets need to orbit at the right distance from their star to support liquid water, perhaps life needs to exist at the right distance from the galactic center to avoid the sterilizing effects of supermassive black hole activity. We're sitting pretty in the galactic suburbs, far enough from the monster to be safe, but close enough to benefit from its gravitational architecture. But safety is relative in a universe full of monsters. While Sagittarius A star isn't going to destroy us tomorrow, its very existence poses questions about the ultimate fate of everything we hold dear. Black holes, you see, are among the most patient predators in the universe. They don't need to hunt. They simply wait, and eventually, everything comes to them. Over cosmic timescales that dwarf human imagination, Sagittarius A star will continue to grow. It will consume gas clouds, devour unlucky stars, and merge with other black holes. Each meal makes it slightly more massive, slightly more powerful, slightly more capable of influencing the galaxy around it. In 1 trillion years, our monster might be 10 times its current size. In 100 trillion years, it might be the only thing left in our galaxy, besides the cold, dead remnants of burned-out stars. This brings us to one of the most haunting predictions in all of astrophysics. The universe is expanding, and that expansion is accelerating, driven by the mysterious force we call dark energy. As space itself stretches, galaxies are being carried apart at ever-increasing speeds. Eventually, billions of years from now, distant galaxies will recede beyond our cosmic horizon, disappearing from view as if they never existed. The Milky Way will become an island universe, alone in an ocean of expanding darkness. And at the heart of that island will sit Sagittarius A star, grown enormous by eons of feeding, the last active object in a galaxy of ghosts. It will be the final lighthouse in our cosmic neighborhood, the last source of energy in a region of space growing cold and empty. But even monsters aren't immortal. Stephen Hawking discovered that black holes emit radiation, slowly evaporating over timescales so vast they make the current age of the universe seem like a fleeting moment. Sagittarius A star will eventually fade away, taking with it the last traces of the galaxy it once ruled. In the end, even the monster will become a memory, a whisper of gravity in an empty cosmos. Yet there's something profoundly beautiful about this cosmic story. We exist during the brief, shining moment when the universe is young and full of energy, when monsters like Sagittarius A star are actively shaping galactic architecture, when stars are being born and planets are forming, and life is emerging on countless worlds across the cosmos. We're witnessing the universe in its prime, and our monster is part of that magnificent spectacle. The story becomes even more remarkable when you consider how we discovered all of this. For most of human history, the monster at our galactic center was completely invisible to us. Our ancestors looked up at the night sky and saw the Milky Way as a gentle river of light, having no idea that it was actually a vast spiral of hundreds of billions of stars held together by an invisible gravitational anchor. The first hint that something massive lurked at the galactic center came from radio astronomy in the 1930s, but it took decades to piece together what those radio signals meant. Scientists had to invent entirely new ways of seeing, develop technologies that didn't exist when the mystery first presented itself. They had to learn to read the language of gravity itself, interpreting the orbital dances of distant stars like cosmic archaeologists, deciphering ancient hieroglyphs. The breakthrough moment came when astronomers realized they could use the stars themselves as probes, natural test particles that revealed the invisible monster's presence through their gravitational ballet. It was like solving a murder case where the only evidence was the way shadows moved across a wall, requiring decades of patient observation to understand what was casting those shadows. The development of adaptive optics technology in the 1990s finally allowed astronomers to track individual stars near the galactic center with unprecedented precision. Suddenly, they could watch stellar orbits unfold in real time, creating time-lapse movies of gravity in action that would have seemed like pure magic to earlier generations of scientists. One of the most extraordinary aspects of this detective story is how it required international collaboration on a scale rarely seen in science. The monster is visible from both hemispheres of Earth, and different telescopes around the world had to work together to maintain continuous observations. Radio telescopes in Puerto Rico, optical telescopes in Chile, X-ray satellites in orbit, infrared observatories on mountaintops in Hawaii, all contributed pieces to the puzzle. The Event Horizon Telescope project, which finally captured the first direct image of Sagittarius A star in 2022, involved telescopes on 6 continents working in perfect synchronization. They had to account for Earth's rotation, atmospheric conditions, equipment failures, and even political tensions that sometimes made international collaboration challenging. The image they produced wasn't just a scientific triumph, it was a testament to human cooperation in the face of cosmic mystery. That first image revealed something both familiar and alien. Sagittarius A star looks remarkably similar to M87K, the supermassive black hole in a distant galaxy that was photographed 3 years earlier. Both show the same characteristic ring of glowing matter surrounding a dark central region, the same asymmetries caused by the extreme rotation of matter in the accretion disk. But there were subtle differences that revealed Sagittarius A star's unique personality. Our monster is much more variable than M87T, flickering and changing brightness on timescales of minutes rather than days. It's like comparing a steady campfire to a strobe light. This variability makes Sagittarius A star much more challenging to photograph, requiring sophisticated computer algorithms to piece together a coherent image from rapidly changing data. The flickering nature of our monster tells us something important about how matter behaves in the extreme environment near a black hole's event horizon. Gas doesn't fall in smoothly and steadily. Instead, it forms hotspots and magnetic field lines that twist and reconnect in chaotic patterns, creating sudden bursts of radiation that light up different parts of the accretion disk unpredictably. These magnetic field interactions are so violent that they can accelerate particles to nearly the speed of light, creating jets of matter that shoot outward from the black hole at incredible velocities. Sagittarius A star's jets aren't as prominent as those from more active supermassive black holes. but they're still powerful enough to carve bubbles in the galactic gas that extend thousands of light years from the monster's lair. Recent observations have revealed that these bubbles, called Fermi bubbles after the space telescope that discovered them, are filled with high-energy particles and magnetic fields that affect the entire galactic environment. The bubbles are like cosmic lungs, breathing energy and matter in and out of the galactic center, in cycles that last millions of years. The discovery of the Fermi bubbles was one of those moments in science when a new observation completely changes your perspective on something you thought you understood. Suddenly, Sagittarius A star wasn't just a gravitational anchor sitting passively at the galactic center. It was an active participant in galactic ecology, pumping energy throughout the Milky Way and influencing processes happening thousands of light years away. This revelation has forced astronomers to reconsider the role of supermassive black holes in cosmic evolution. They're not just endpoints of gravitational collapse. They're cosmic engines that regulate star formation, distribute heavy elements, and shape the large-scale structure of the universe. The monster at our galactic center isn't just holding our galaxy together. It's actively managing its development like a cosmic gardener tending to a billion-star ecosystem. The management system is incredibly sophisticated. When Sagittarius A star feeds actively, it releases energy that heats up gas clouds throughout the inner galaxy, preventing them from cooling and collapsing to form new stars. This creates a negative feedback loop that regulates star formation rates and prevents the galaxy from burning through its gas supply too quickly. But the system also includes positive feedback mechanisms. The energy released by the monster can trigger star formation in certain regions by compressing gas clouds or by enriching them with heavy elements ejected from the black hole's vicinity. The result is a complex dance of creation and destruction that has been choreographed by gravity over billions of years. Understanding this dance has become one of the holy grails of modern astrophysics. Scientists are using supercomputers to simulate the interaction between supermassive black holes and their host galaxies, trying to reproduce the observed properties of real galaxies like our own. These simulations require some of the most powerful computers on Earth, modeling the behavior of millions of particles over billions of years of cosmic evolution. The simulations reveal that the relationship between Sagittarius A star and the Milky Way is far more intimate than anyone initially suspected. The monster doesn't just influence its immediate surroundings. Its gravitational effects ripple outward through the entire galactic disk, affecting the orbits of stars tens of thousands of light years away. Every star in our galaxy, including our Sun, carries the subtle signature of the monster's gravitational influence in its orbital motion. This means that Sagittarius A star has been shaping our cosmic neighborhood for the entire 4.6 billion year history of our solar system. The monster's gravity helped determine the particular orbit our Sun follows around the galactic center, which in turn influence the rate at which our solar system encounters molecular clouds, stellar nurseries, and other galactic hazards that could affect life on Earth. We're not just passengers in a galaxy that happens to contain a supermassive black hole. We're products of that black hole's influence, shaped by billions of years of cosmic evolution orchestrated by the monster at our galactic center. The calcium in our bones, the iron in our blood, the oxygen we breathe, all of these elements were processed through stellar life cycles that were themselves influenced by Sagittarius A star's regulation of galactic star formation. In a very real sense, we are children of the monster, forged in the cosmic furnace that it has been tending for eons. But this intimate connection raises a question that keeps cosmologists awake at night. If Sagittarius A star has such profound influence over our galaxy's development, what happens when it changes its behavior? What happens when the monster wakes up from its current slumber and begins feeding again? The answer might be written in the geological record of our own planet. Some scientists have proposed that past feeding frenzies of Sagittarius A star could have influenced Earth's climate, and even the evolution of life itself. When the monster becomes active, it doesn't just heat up gas in the galactic center. It launches high-energy particles and radiation that can travel thousands of light years, potentially affecting the cosmic ray environment throughout the galaxy. Cosmic rays are like invisible bullets of energy that constantly bombard Earth from space. Our planet's magnetic field and atmosphere protect us from most of this radiation, but changes in the cosmic ray flux could still influence cloud formation, climate patterns, and even mutation rates in living organisms. It's possible that some of the major evolutionary transitions in Earth's history coincide with periods of increased activity from our galactic monster. This connection between the monster at our galactic center and life on Earth represents one of the most profound examples of cosmic ecology ever discovered. We're not isolated on our small blue planet, insulated from the vast forces operating in deep space. We're part of an interconnected system that spans the entire galaxy, where events happening 26,000 light years away can influence the development of consciousness on a rocky world orbiting an ordinary star. But the monster's influence extends beyond our own galaxy. Sagittarius A star is part of a cosmic hierarchy of supermassive black holes that stretches across the observable universe. These monsters communicate with each other through gravitational waves, ripples in space-time, that carry information about their masses, spins, and orbital dynamics across intergalactic distances. When two supermassive black holes merge, they create gravitational wave signatures so powerful that they can be detected by observatories on Earth, even when the merger happens billions of light years away. These cosmic collisions are like notes in a symphony of space-time, each one telling us something about the population of monsters scattered throughout the universe. The gravitational wave detectors that first confirmed Einstein's predictions about ripples in space-time have opened an entirely new window into the monster-filled cosmos. We're now able to eavesdrop on the conversations between black holes, listening to their final moments as they spiral toward each other in cosmic death dances that release more energy than entire galaxies produce in light. These observations have revealed that supermassive black holes are far more common than anyone expected. Nearly every large galaxy appears to harbor a monster at its center, and the masses of these black holes are tightly correlated with the properties of their host galaxies. It's as if the monsters and their galaxies grew up together, each shaping the other's development through billions of years of cosmic evolution. This correlation, known as the black hole galaxy mass relationship, suggests that the formation of supermassive black holes and the formation of galaxies are intimately connected processes. The monsters aren't just passengers riding along in pre-existing galaxies. They're fundamental components of galactic architecture, as essential to a galaxy's structure as the nucleus is to an atom. The discovery of this relationship has revolutionized our understanding of how the universe evolved from the smooth, nearly featureless state revealed by the cosmic microwave background to the rich tapestry of galaxies, stars, and planets we see today. The monsters weren't just observers of cosmic evolution, they were active participants, architects of the large-scale structure that defines our universe. But here's where the story takes an even more remarkable turn. The monster at our galactic center might not be unique in its current quiet behavior. Observations of other galaxies suggest that supermassive black holes go through cycles of activity and dormancy that can last millions or even billions of years. Some galaxies show evidence of ancient feeding frenzies that ended long ago, leaving behind only the fossilized remains of massive outflows and shockwaves in the galactic gas. Other galaxies are caught in the act of feeding their monsters, their central regions blazing with the light of matter, falling into supermassive black holes at prodigious rates. These active galactic nuclei can outshine the combined light of all the stars in their host galaxies, creating beacons visible across billions of light-years of space. The most extreme examples are called quasars, supermassive black holes feeding so voraciously that they become the brightest objects in the universe. A single quasar can emit more energy than 1,000 galaxies, powered entirely by matter falling into a region no larger than our solar system. These cosmic lighthouses mark the locations of the most massive monsters in the universe, feeding frenzies so intense they can be seen from the very edge of the observable cosmos. When astronomers look at quasars, they're seeing what Sagittarius A star might have looked like billions of years ago, during the early epochs of galactic formation, when gas was abundant and feeding rates were much higher. Our monster was probably much more active in its youth, blazing across the cosmos like a cosmic searchlight during the wild early days of the Milky Way's development. The transition from active quasar to quiet supermassive black hole represents one of the most dramatic transformations in cosmic evolution. As galaxies mature and exhaust their gas supplies, their central monsters gradually starve, fading from brilliant beacons to nearly invisible gravitational anchors. Sagittarius A star has undergone this transition, settling into the quiet retirement of a well-fed predator in a galaxy that has reached middle age. But retirement doesn't mean death. The monster is simply waiting, patient as only a black hole can be, for the next opportunity to feed. That opportunity could come from several sources. Gas clouds occasionally wander too close to the galactic center, providing fuel for brief periods of increased activity. Unlucky stars sometimes have their orbits perturbed, sending them on collision courses with the monster's accretion disk. More dramatically, the eventual collision with Andromeda will provide Sagittarius A star with a feast unlike anything it has experienced in billions of years. The gravitational chaos of the galactic merger will send streams of gas spiraling toward both supermassive black holes, triggering feeding frenzies that will light up both galaxies like cosmic fireworks displays. The merger will also bring our monster face to face with its counterpart from Andromeda, setting up a gravitational dance that will last millions of years as the two black holes spiral toward each other. This cosmic ballet will be one of the most spectacular events in the local group of galaxies, a slow-motion collision between titans that will reshape the gravitational landscape of our cosmic neighborhood. When the two monsters finally merge, they'll create gravitational waves so powerful that they'll be detectable by observatories throughout the local group and beyond. The merger will birth a new, even more massive, supermassive black hole, a cosmic emperor ruling over the combined remnants of two ancient galactic civilizations. But that merger is still billions of years in the future. For now, Sagittarius A star continues its patient watch over our galaxy, maintaining the gravitational order that has allowed complex chemistry and biology to flourish in places like our solar system. The monster is both our creator and our ultimate destiny, the force that shaped our cosmic environment and the entity that will eventually inherit whatever remains of our galactic civilization. This duality, creator and destroyer, architect and entropy, captures something essential about the role of supermassive black holes in cosmic evolution. They're not simply endpoints of gravitational collapse, cosmic vacuum cleaners mindlessly consuming everything in their path. They're sophisticated regulatory systems that have been managing galactic ecosystems for billions of years, creating the conditions necessary for stars, planets, and life, while simultaneously representing the ultimate fate of all matter in the universe. The monster at our galactic center embodies this cosmic paradox. It's the reason we exist and the guarantee that our existence is temporary. It created the stable galactic environment that allowed our sun to burn steadily for billions of years. But it will also be here long after our sun has exhausted its nuclear fuel and faded to a cold white dwarf. Understanding this paradox requires us to think about time on scales that dwarf human experience. The monster operates on cosmic timescales where millions of years pass like seconds, where the rise and fall of entire civilizations are brief flickers in an eternal gravitational dance. From its perspective, the entire history of life on Earth is just a momentary burst of complexity in an otherwise quiet corner of the galaxy. Yet from our perspective, trapped as we are in the narrow slice of cosmic history when intelligence has emerged and begun to contemplate its own existence, the monster represents both mystery and opportunity. Every observation of Sagittarius A star teaches us something new about the fundamental nature of gravity, space-time, and the large-scale structure of the universe. The monster is our local laboratory for testing the most extreme predictions of Einstein's theory of general relativity. The environment near its event horizon represents conditions so extreme that they push our understanding of physics to its absolute limits. Quantum mechanics and general relativity, the two pillars of modern physics, must somehow work together to describe what happens in the monster's domain. But we don't yet have a complete theory of quantum gravity to guide us. This gap in our understanding makes Sagittarius A star more than just an astronomical object. It's a cosmic Rosetta Stone, a natural experiment that might help us decode the deepest laws of physics. The monster is writing the equations of reality in the orbital paths of nearby stars, in the behavior of infalling matter, in the structure of space-time itself. Every new observation brings us closer to understanding these equations, but they also reveal how much we still don't know. The monster keeps its secrets well, hiding them behind event horizons where information cannot escape, in regions where the very concepts of space and time break down according to our current theories. But perhaps the most remarkable secret that Sagittarius A star has revealed is the interconnectedness of cosmic evolution. The monster has shown us that galaxies, stars, and planets don't evolve in isolation. They're part of a vast, interconnected web of gravitational relationships that spans the entire observable universe. The calcium in our bones was processed through stellar nucleosynthesis rates regulated by supermassive black holes. The iron in our blood was scattered by supernovae whose timing was influenced by galactic-scale feedback processes, orchestrated by monsters like Sagittarius A star. Even the water we drink carries the chemical signature of cosmic evolution, guided by supermassive black holes over billions of years. We are not separate from the monster at our galactic center. We are part of its extended family, products of the cosmic ecosystem it has been managing since before Earth existed. In studying Sagittarius A star, we're not just learning about a distant astronomical object. We're discovering our own cosmic genealogy, tracing our origins back to the fundamental forces that have been shaping the universe since its earliest moments. This realization transforms how we think about our place in the cosmos. We're not accidental byproducts of random processes operating in an indifferent universe. We're integral components of cosmic evolution, temporary arrangements of matter and energy that have achieved the remarkable ability to contemplate the very forces that created us. The monster at our galactic center has been waiting patiently for billions of years for moments like this, when the universe becomes aware of itself through the emergence of conscious beings capable of understanding their cosmic heritage. In a very real sense, we are the monster's way of studying itself, its method of achieving self-awareness through the evolution of intelligence in the galaxies it governs. This perspective doesn't diminish our significance. If anything, it magnifies it. We represent a remarkable achievement in cosmic evolution, the emergence of complexity and consciousness from the gravitational architecture orchestrated by supermassive black holes. We are the universe's most sophisticated attempt at self-understanding, and our studies of monsters like Sagittarius A* are cosmic evolution becoming conscious of its own processes. The story of how we discovered the monster at our galactic center is really the story of how the universe learned to see itself. Through our telescopes and theories, through our patient observations and bold hypotheses, cosmic evolution has developed eyes and minds capable of perceiving its own deepest structures. And the story is far from over. New telescopes coming online in the next decade will peer deeper into the monster's domain than ever before, revealing details of the environment near the event horizon that we can barely imagine. Space-based gravitational wave detectors will listen for the whispers of space-time as matter falls into black holes throughout the universe. Advanced computer simulations will model the behavior of matter and energy in gravitational fields so extreme they defy human intuition. Each new discovery will add another chapter to the remarkable story of Sagittarius A* and its role in cosmic evolution. But perhaps the most important chapter is the one being written right now as conscious beings scattered across a small planet take their first tentative steps toward understanding the monster that has shaped their existence since before they were born. We stand at the threshold of a new era in our relationship with the cosmos, an age when we're beginning to understand our true cosmic heritage and our intimate connection to the forces that govern reality itself. The monster at the heart of our galaxy is no longer just a distant curiosity. It's family, the ancient architect of the cosmic environment that made our existence possible. And in that recognition, in that moment of cosmic understanding, perhaps we catch a glimpse of what the universe has been trying to achieve through billions of years of evolution, the emergence of consciousness capable of comprehending the magnificent, terrifying, beautiful monster that has been guiding our destiny from the very beginning. The relationship between time and space near Sagittarius A* reveals one of the universe's most profound mysteries. As you get closer to the monster, time doesn't just slow down. It becomes elastic, stretching and compressing in ways that challenge every assumption we have about the nature of reality itself. A clock placed near the event horizon would tick at a different rate than one here on Earth, not because of mechanical failure, but because time itself flows differently in the monster's gravitational embrace. This isn't theoretical physics anymore, it's measurable reality. The stars orbiting closest to Sagittarius A* are natural timepieces, their light carrying the signature of temporal distortion across 26,000 light-years of space. When astronomers analyze the spectrum of light from these stellar test particles, they can detect the subtle ways that gravity warps the passage of time itself. The implications are staggering. If you could somehow survive a journey to the monster's edge and return to Earth, you would find that centuries had passed while you experienced only hours. The people you left behind would be long dead, their civilizations risen and fallen, while you remained virtually unchanged by the passage of what we call time. The monster doesn't just bend space, it bends the very flow of existence itself. But here's what makes this truly mind-bending. The distortion of time near Sagittarius A star means that the monster exists in a different temporal reference frame than the rest of our galaxy. Events that seem to unfold over millions of years from our perspective might appear to happen much more rapidly to an observer near the black hole. The monster experiences cosmic evolution at a different pace than the stars it governs. This temporal complexity adds layers to our understanding of how supermassive black holes interact with their galactic environments. The feedback loops that regulate star formation don't just operate across vast distances of space, they operate across different flows of time, creating a four-dimensional dance of matter, energy, and temporal distortion that we're only beginning to comprehend. The monster's influence on time extends far beyond its immediate vicinity. The gravitational waves produced by matter falling into Sagittarius A star carry information about temporal distortion across the galaxy. These ripples in space-time are like temporal messengers, spreading the monster's influence through both space and time simultaneously. Recent theoretical work suggests that the monster might even influence the arrow of time itself. In regions of extreme gravitational distortion, the usual relationship between cause and effect becomes blurred. Events that we would normally consider sequential might become simultaneous or even reversed from certain perspectives. The monster creates pockets of space-time where the familiar logic of temporal sequence breaks down entirely. This breakdown of temporal logic has profound implications for our understanding of information and consciousness. If time flows differently near the monster, then information processing itself must operate according to different rules. Any form of intelligence that evolved in the monster's immediate vicinity would experience reality in ways that are literally inconceivable to minds like ours, shaped by billions of years of evolution in regions where time flows steadily forward. The monster forces us to confront the possibility that consciousness itself might be a temporal phenomenon, dependent on the particular flow of time that exists in our corner of the galaxy. We think of awareness as something that exists in the present moment, but near Sagittarius A star, the very concept of a present moment becomes meaningless. Past, present, and future blend into a temporal soup where linear thinking cannot survive. This temporal complexity reveals why the monster has remained mysterious for so long. We've been trying to understand it using concepts of time and causality that simply don't apply in its domain. It's like trying to understand music by looking at a single note, or trying to comprehend a movie by examining one frame. The monster operates on scales of space and time that transcend our ordinary experience. But the monster's mysteries extend beyond the warping of space-time. Deep within its accretion disk, matter behaves in ways that challenge our understanding of physics itself. As gas and dust spiral toward the event horizon, they reach temperatures of billions of degrees, hot enough to strip electrons from atomic nuclei and create a plasma so energetic that it glows across the entire electromagnetic spectrum. In this hellish environment, magnetic fields become twisted into complex geometries that would be impossible anywhere else in the universe. These magnetic structures can store and release energy in sudden, violent bursts that launch jets of particles at nearly the speed of light. The monster becomes a cosmic particle accelerator, creating energies that dwarf anything we can produce on Earth. The particles accelerated by Sagittarius A star don't just disappear into space. They carry information about the monster's feeding habits across vast distances, creating a cosmic telegraph system that broadcasts the black hole's activity throughout the galaxy. When the monster feeds, radio telescopes on Earth can detect the afterglow of its meal within hours or days. This real-time connection between Earth and the galactic center represents one of the most remarkable achievements in modern astronomy. We can now monitor the monster's behavior almost as it happens, watching gas clouds get shredded and consumed in processes that release more energy than entire star systems produce over their lifetimes. The monitoring has revealed that Sagittarius A star is surprisingly finicky about its food. The monster doesn't consume everything that comes near it. Instead, it seems to sample different types of matter, sometimes rejecting gas clouds that appear perfectly suitable for consumption. This selective feeding behavior suggests that the physics of black hole accretion is far more complex than anyone initially suspected. The monster's dietary preferences might be related to the magnetic properties of infalling matter. Gas clouds with certain magnetic field orientations might be easier to digest than others. Or perhaps the monster's feeding is influenced by the rotation rate of the accretion disk, which could create resonances that either enhance or inhibit the infall of matter. Understanding these feeding mechanisms has become one of the hottest topics in black hole physics. Scientists are using supercomputers to simulate the complex magnetohydrodynamics of matter falling into supermassive black holes, trying to reproduce the observed feeding patterns of monsters like Sagittarius A star. The simulations reveal that the environment around a supermassive black hole is far from the simple picture of matter spiraling smoothly inward that was once imagined. Instead, it's a chaotic maelstrom of magnetic fields, shock waves, and turbulent flows that create conditions unlike anything else in the universe. Matter doesn't fall straight into the monster. It gets caught up in magnetic tornadoes that can persist for months or years before finally delivering their contents to the event horizon. These magnetic tornadoes are visible in radio observations as bright spots that orbit around the monster at incredible speeds. Astronomers can track these spots as they spiral inward, watching matter take its final journey into the abyss. It's like having a front row seat to the most extreme gravitational show in the galaxy. But the monster's influence extends far beyond its immediate feeding habits. Sagittarius A star sits at the center of a vast ecosystem of gas, dust, and stars that stretches across hundreds of light years. This ecosystem responds to the monster's every mood, brightening when it feeds actively and dimming when it goes quiet. The ecosystem includes some of the most extreme stellar environments in the galaxy. Stars near the galactic center are subjected to intense tidal forces that stretch and compress them as they orbit the monster. Some stars have been stretched into elongated shapes that would be impossible anywhere else in the universe. Others have been stripped of their outer layers, leaving behind exposed stellar cores that burn with unusual brightness. These extreme stellar environments serve as natural laboratories for studying how matter behaves under conditions that cannot be replicated on Earth. The stars themselves become scientific instruments. Their light carrying information about gravitational fields, magnetic interactions, and nuclear processes operating in the monster's domain. One of the most remarkable discoveries has been the existence of stars that appear to be made almost entirely of helium. These bizarre objects, found only in the immediate vicinity of Sagittarius A star, might be the remnants of normal stars that had their hydrogen envelopes stripped away by the monster's tidal forces. They represent a new category of stellar evolution that occurs only in the gravitational field of supermassive black holes. The monster has also created a population of hypervelocity stars, objects that have been accelerated to such high speeds by gravitational encounters that they're escaping from the galaxy entirely. These stellar refugees carry information about their violent encounters with the monster as they flee toward intergalactic space at speeds of hundreds of miles per second. Tracking hypervelocity stars has become a new way of studying the monster's gravitational influence. Each escaped star tells a story about a close encounter with Sagittarius A star, providing clues about the black hole's mass, spin, and feeding history. It's like studying the aftermath of cosmic car accidents, using the trajectory of ejected debris to understand what happened during the collision. The monster's creation of hypervelocity stars also raises fascinating questions about the distribution of life in the universe. If any of these escaped stars have planets, those worlds are now traveling between galaxies, carrying whatever life they might harbor into the vast emptiness of intergalactic space. The monster might be inadvertently seeding the universe with life, launching biological experiments on journeys that will last for billions of years. But the monster's influence on life might be more direct than anyone initially suspected. Recent research has suggested that the cosmic rays produced by Sagittarius A star's feeding activities might play a role in driving genetic mutations on Earth. The high-energy particles launched by the monster travel throughout the galaxy, and when they interact with Earth's atmosphere, they create cascades of secondary particles that can penetrate to the planet's surface. These cosmic ray showers are constantly bombarding every living thing on Earth, causing DNA damage that drives evolutionary change. The rate of cosmic ray bombardment varies depending on our solar system's position in the galaxy and the activity level of Sagittarius A star. This means that the monster might be directly influencing the pace of evolution on our planet, accelerating genetic change when it feeds actively, and allowing evolutionary processes to slow when it goes quiet. The connection between the monster's feeding habits and the evolution of life on Earth represents one of the most profound examples of cosmic ecology ever discovered. We're not just products of stellar nucleosynthesis and planetary formation. We might be direct products of the monster's influence, shaped by billions of years of cosmic ray bombardment that traces back to feeding frenzies in the galactic center. This realization has led some scientists to propose that the monster might play a role in the timing of mass extinction events on Earth. If Sagittarius A star goes through cycles of activity and dormancy, those cycles might correlate with periods of increased cosmic ray bombardment that stress Earth's biosphere. The monster might be a cosmic clock that regulates the pace of evolutionary change throughout the galaxy. Testing this hypothesis requires understanding the monster's long-term behavior patterns, which means looking back through billions of years of galactic history. Fortunately, the monster has left geological evidence of its past activities in the form of ancient star formation patterns, chemical abundances in old stellar populations, and the large-scale structure of the galactic gas distribution. Reading this geological record of galactic evolution is like deciphering an ancient text written in the language of gravity and nuclear physics. Each generation of stars carries chemical signatures that reveal the conditions under which they formed, including the influence of the monster's regulatory feedback mechanisms. By studying stellar populations of different ages, astronomers can reconstruct the monster's feeding history over cosmic time. The record reveals that Sagittarius A star was much more active in the past, particularly during the early epochs of galactic formation, when gas was abundant and merger events were more common. The monster's youth was violent and chaotic, marked by feeding frenzies that would have sterilized vast regions of the galaxy with deadly radiation. As the galaxy matured and settled into its current structure, the monster's feeding rate declined, allowing the formation of stable stellar populations like the one that includes our Sun. We exist during a relatively quiet period in the monster's life cycle, benefiting from billions of years of galactic evolution that has created the calm conditions necessary for complex chemistry and biology. But this quiet period won't last forever. The monster is simply waiting for its next meal, and when that meal arrives, our entire cosmic neighborhood will be transformed by the resulting burst of energy and radiation. The transformation won't necessarily be destructive. It might actually trigger new rounds of star formation and galactic evolution that create opportunities for life in regions that are currently sterile. Understanding the monster's future behavior has become one of the most important goals in galactic astronomy. Scientists are using computer models to predict when the next major feeding event might occur and what its consequences might be for our solar system. The models suggest that we're relatively safe from direct effects, but the indirect consequences could still be significant. The most likely trigger for the monster's next feeding frenzy will be the eventual collision with Andromeda Galaxy. The gravitational chaos of that merger will send streams of gas flowing toward both supermassive black holes, providing fuel for the most spectacular light show our cosmic neighborhood has seen in billions of years. But even before the Andromeda collision, smaller feeding events could dramatically change the monster's behavior. Gas clouds occasionally wander into the galactic center, and their consumption by Sagittarius A star creates brief periods of increased activity that can be detected across the electromagnetic spectrum. The most dramatic recent example was the approach of a gas cloud designated G2, which passed within 120 times Earth's distance from the Sun as it orbited the monster in 2014. Astronomers around the world held their breath as the cloud approached, expecting to witness a major feeding event that would increase the monster's brightness by factors of hundreds or thousands. The feeding event was more subtle than expected, but it still provided unprecedented insights into how the monster consumes matter. Advanced telescopes tracked the cloud's disruption in real time, watching as it was stretched and heated by tidal forces before being partially consumed by the accretion disk. The G2 event revealed that the monster's feeding process is far more complex than a simple gravitational free fall. The cloud's material became entangled with magnetic field lines in the accretion disk, creating a complex web of plasma streams that took months to settle into stable orbital patterns. Some of the cloud's material was ejected back into the galactic environment, while other portions spiraled inward toward the event horizon. This partial consumption pattern appears to be typical of how Sagittarius A star feeds. The monster is surprisingly inefficient, consuming only a small fraction of the matter that comes within its gravitational influence. Most infalling material gets heated and ejected back into the galactic environment, carrying energy and enriched chemical elements that influence star formation throughout the inner galaxy. The monster's inefficient feeding habits are actually crucial for galactic evolution. If Sagittarius A star consumed matter too efficiently, it would grow rapidly and become so massive that its gravitational influence would destabilize the entire galaxy. The inefficiency creates a natural regulatory mechanism that prevents the monster from growing beyond the size that's optimal for maintaining galactic structure. This self-regulation represents one of the most elegant examples of cosmic feedback in the universe. The monster has evolved a feeding strategy that maximizes its long-term survival while maintaining the galactic ecosystem that provides its food supply. It's like a cosmic farmer that knows not to harvest too much of the crop in any given season. The regulatory mechanisms become even more sophisticated when you consider the monster's interaction with dark matter, the invisible substance that makes up most of the galaxy's mass. Dark matter doesn't interact electromagnetically, so it can't be heated and ejected like ordinary matter. Instead, it accumulates around supermassive black holes, creating dense halos that influence the dynamics of ordinary matter halo around Sagittarius A star might matter in subtle but important ways. The dark contain clues about the monster's formation history and its role in galactic evolution. Computer simulations suggest that supermassive black holes and dark matter halos grew together during the early epochs of cosmic structure formation, with each influencing the other's development through gravitational feedback processes. Understanding this co-evolution requires sophisticated models that track both dark matter and ordinary matter over billions of years of cosmic time. The models reveal that the monster's current mass and the structure of its dark matter halo are intimately connected, each reflecting the other's influence during the galaxy's formation and early evolution. The dark matter halo also provides a natural explanation for some of the mysterious objects orbiting near the galactic center. Several of the supposed gas clouds in the region might actually be dark matter clumps that became visible when they interacted with the monster's accretion disk. These hybrid objects represent a new category of astronomical phenomena that exists only in the extreme environment near supermassive black holes. The discovery of dark matter interactions near Sagittarius A star has opened new avenues for studying the invisible substance that dominates our galaxy's mass. The monster's extreme gravitational field creates conditions that might make dark matter detectable through processes that would be impossible anywhere else in the universe. Some theoretical models suggest that dark matter particles might annihilate each other when concentrated in the intense gravitational field near the monster, producing gamma rays that could be detected by space-based telescopes. Other models propose that dark matter might interact with the monster's magnetic field in ways that create observable signatures in radio or X-ray emissions. The search for dark matter signatures from Sagittarius A star represents one of the most exciting frontiers in both astronomy and particle physics. If successful, it would provide the first direct evidence for dark matter interactions and reveal fundamental properties of the invisible substance that makes up most of our universe. But even if dark matter remains elusive, the monster continues to reveal new secrets about the nature of gravity and space-time. Recent observations have detected subtle variations in the monster's gravitational field that might be signatures of its rotation or spin. Measuring the spin of Sagittarius A star is one of the holy grails of black hole physics, because it would provide crucial information about the monster's formation history and current state. A rapidly spinning black hole creates a phenomenon called frame dragging, where the rotation of the black hole literally drags space-time along with it. This effect would influence the orbits of nearby stars in ways that are detectable with sufficiently precise observations. By tracking the subtle precession of stellar orbits around the monster, astronomers might be able to measure its spin rate directly. The spin measurement would answer fundamental questions about how Sagittarius A star formed and grew over cosmic time. Black holes formed from the collapse of single stars tend to have moderate spin rates, while those formed from the merger of multiple objects can spin much more rapidly. The monster's current spin would provide clues about whether it grew primarily through steady accretion or through dramatic merger events. Understanding the monster's spin is also crucial for predicting its future behavior. The spin rate determines how efficiently the black hole can extract energy from infalling matter, which in turn influences its feeding patterns and the energy output that regulates galactic star formation. A rapidly spinning monster would be a more efficient engine for converting matter into energy, creating stronger feedback effects throughout the galaxy. The measurement of Sagittarius A star's spin represents the cutting edge of observational astronomy, requiring techniques and instruments that push technology to its absolute limits. The effects being measured are incredibly subtle, requiring years of patient observation and sophisticated data analysis to extract meaningful results from the cosmic noise. But the effort is worthwhile because understanding the monster's fundamental properties will unlock secrets about the deepest workings of the universe itself. Sagittarius A star is more than just the gravitational anchor of our galaxy. It's a natural laboratory where the most extreme predictions of physics play out on scales that dwarf human imagination. Every new measurement, every refined observation, every theoretical breakthrough brings us closer to understanding not just the monster at our galactic center, but the fundamental nature of reality itself. We are witnesses to one of the most remarkable chapters in the history of human discovery. The moment when our species first began to comprehend the true nature of the cosmic forces that shaped our existence. The monster that once lurked invisible in the galactic darkness has become our teacher, revealing secrets about gravity, space-time, and cosmic evolution that we never knew existed. Through patient observation and bold theoretical leaps, we've learned to see the unseeable, to understand the incomprehensible, to find beauty in the terrifying. And the monster continues to surprise us, continues to challenge our assumptions, continues to reveal new layers of cosmic complexity that we're only beginning to explore. Each answer leads to new questions. Each discovery opens new frontiers of investigation. Each breakthrough reveals how much more there is to learn about the magnificent, mysterious, absolutely essential monster that has been guiding our cosmic destiny since before time began. We stand at a crossroads in human understanding, where the monster we've been studying reveals something even more profound about the nature of existence itself. Because Sagittarius A star isn't just teaching us about black holes or galactic dynamics. It's showing us that the universe operates on principles so alien to our everyday experience that they challenge the very foundations of logic and reason. Consider what happens to information that falls into the monster. In our ordinary world, information is conserved. If you burn a book, the information isn't destroyed. It's just scrambled into smoke and ash in ways that are theoretically recoverable. But when information crosses the event horizon of Sagittarius A star, it seems to vanish completely from our universe. This creates what physicists call the information paradox, one of the deepest unsolved mysteries in modern science. The paradox emerges from the collision between two of our most successful theories. Quantum mechanics insists that information must be conserved, that nothing can truly disappear from the universe. But general relativity suggests that anything crossing a black hole's event horizon is gone forever, lost to a region of space-time from which no information can ever escape. One of these theories must be wrong, or our understanding of both must be incomplete. Some scientists propose that the information isn't really lost, that it's somehow encoded on the surface of the event horizon in ways we don't yet understand. Others suggest that the interior of black holes might be connected to other regions of space-time through quantum entanglement, creating bridges that allow information to escape through alternate routes. Still others propose that the very concept of an event horizon might be an illusion, that what we call a black hole is actually something far stranger and more complex. The resolution of this paradox will require a theory of quantum gravity that successfully merges our understanding of the very large with our knowledge of the very small. Sagittarius A star has become the testing ground for these theories, a cosmic laboratory where the most fundamental laws of physics are pushed to their breaking points. But the monster's lessons extend beyond the arcane realms of theoretical physics. It's teaching us about the nature of time itself, revealing that our intuitive understanding of temporal flow is just one perspective on a far more complex reality. Near the monster's event horizon, time doesn't just slow down or speed up. it becomes multidimensional, branching and converging in ways that make linear causality meaningless. This temporal complexity has profound implications for consciousness and free will. If time is truly multidimensional near the monster, then the choices made by any intelligence in that region might simultaneously create multiple timelines, each representing different possible outcomes. The monster exists in a realm where quantum superposition applies not just to particles, but to entire sequences of cause and effect. The philosophical implications are staggering. Free will, determinism, the arrow of time, the nature of consciousness itself, all of these concepts that seem fundamental to human existence become fluid and uncertain in the monster's domain. We're forced to confront the possibility that our most basic assumptions about reality are valid only in the relatively calm gravitational environment of our cosmic neighborhood. This realization has led some theorists to propose that consciousness itself might be a gravitational phenomenon, emerging only in regions of space-time where temporal flow is sufficiently regular and predictable. The monster creates conditions where traditional consciousness might be impossible, replaced by forms of awareness that operate according to principles we can barely imagine. But even as the monster challenges our understanding of individual consciousness, it reveals something beautiful about collective intelligence and the nature of scientific discovery itself. The story of how we detected and studied Sagittarius A* is really the story of human civilization learning to think on cosmic scales, developing the intellectual tools necessary to comprehend phenomena that transcend individual human experience. The discovery required unprecedented levels of international cooperation, with astronomers from dozens of countries working together over multiple decades to piece together the monster's secrets. No single human mind could have comprehended the full scope of the problem, but collective human intelligence, distributed across generations of scientists and supported by increasingly sophisticated technology, was able to achieve what seemed impossible just a century ago. This collective achievement represents a new form of consciousness emerging at the species level, a distributed intelligence capable of understanding phenomena that individual brains cannot grasp. We've become a cosmic sensor array, using our telescopes as extended senses and our theories as shared memory systems that allow knowledge to accumulate across generations. The monster has catalyzed this evolutionary leap in human consciousness, forcing us to develop new ways of thinking about space, time, and causality. In studying Sagittarius A*, we've had to transcend the limitations of individual perception and create conceptual frameworks that can encompass phenomena operating on scales of space and time that dwarf human experience. But the monster's influence on human consciousness goes deeper than just scientific discovery. It's changing how we see ourselves in relation to the cosmos, revealing that we're not separate observers studying a foreign universe, but integral components of cosmic evolution itself. The atoms in our bodies were processed through stellar life cycles regulated by monsters like Sagittarius A*. The elements that make consciousness possible were distributed throughout the galaxy by processes orchestrated by supermassive black holes. We are, in the most literal sense, children of the monster, products of billions of years of cosmic evolution guided by the gravitational influence of supermassive black holes. Our thoughts, our emotions, our capacity for wonder and discovery, all of these emerge from matter that has been shaped by the monster's influence since before Earth existed. This recognition transforms the very meaning of scientific investigation. When we study Sagittarius A*, we're not just learning about a distant astronomical object. We're discovering our own cosmic genealogy, tracing our origins back to the fundamental forces that have been shaping the universe since its earliest moments. The monster has shown us that scientific understanding is not just an intellectual exercise, but a form of cosmic self-recognition. Through our telescopes and equations, the universe is learning to see itself, to understand its own deepest structures and processes. We are the cosmos awakening to its own nature, temporary arrangements of matter and energy that have achieved the extraordinary capacity for self-reflection. This perspective doesn't diminish the importance of human consciousness. If anything, it magnifies our cosmic significance. We represent one of the universe's most sophisticated attempts at self-understanding. Biological computers capable of processing information about phenomena that operate on scales vastly larger than ourselves. The monster has revealed that consciousness might be one of the most important phenomena in cosmic evolution, the mechanism through which the universe develops the capacity to understand and perhaps even influence its own development. Through conscious beings like ourselves, cosmic evolution becomes self-aware, capable of contemplating its own past and future. But consciousness also creates responsibility. If we are the universe's way of understanding itself, then our scientific discoveries carry profound moral weight. Every breakthrough in our understanding of monsters like Sagittarius A star adds to the cosmos's capacity for self-knowledge. Every failure to pursue that understanding represents a lost opportunity for the universe to comprehend its own nature. The monster challenges us to think beyond the narrow confines of terrestrial concerns and embrace our role as cosmic citizens. The same gravitational forces that govern Sagittarius A star also influence the development of life throughout the galaxy. Our studies of the monster contribute to a growing understanding of how supermassive black holes regulate the conditions necessary for biology and consciousness throughout the universe. This knowledge has practical implications that extend far beyond academic curiosity. Understanding how monsters like Sagittarius A star influence galactic environments will be crucial for humanity's eventual expansion into space. As we develop the capability to travel between star systems, we'll need to understand the cosmic forces that shape galactic habitability. The monster's regulatory influence on star formation, its role in distributing heavy elements, its impact on cosmic ray environments, all of these factors will determine which regions of the galaxy are suitable for life and which are too hostile for biological processes. Sagittarius A star is writing the environmental conditions that will constrain humanity's cosmic future. But the monster also offers opportunities that we're only beginning to recognize. The extreme gravitational fields near supermassive black holes create conditions that might be exploited for energy production, space travel, or even information processing on scales that dwarf anything possible on planetary surfaces. Advanced civilizations might learn to harness the rotational energy of spinning black holes, tapping into power sources that make stellar fusion seem primitive by comparison. The monster's ability to accelerate particles to near light speed might also provide propulsion systems for interstellar travel that are currently beyond our technological reach. By carefully maneuvering spacecraft in the gravitational field of Sagittarius A star, future explorers might be able to achieve velocities that would allow travel to nearby star systems within human lifetimes. These possibilities remain speculative, but they illustrate how the monster might transition from being a subject of study to becoming a tool for cosmic exploration. The same gravitational forces that we now observe from a safe distance might one day become highways for interstellar commerce and communication. But realizing these possibilities will require a level of understanding that we haven't yet achieved. We need to develop technologies capable of operating in the extreme conditions near supermassive black holes, materials that can withstand intense radiation and gravitational stresses, navigation systems that can function where space and time are warped beyond recognition. The challenges are immense, but the potential rewards are even greater. The monster holds keys to technologies and energy sources that could transform human civilization, opening possibilities for growth and development that are currently unimaginable. We stand at the beginning of a relationship with Sagittarius A* that might last for millions or billions of years, evolving from passive observation to active utilization. This long-term perspective reveals another profound truth about the monster's significance. Sagittarius A* will outlast our sun, our solar system, perhaps even our species. Long after Earth has been consumed by our aging star, the monster will still be anchoring whatever remains of our galaxy, presiding over cosmic processes that we can barely comprehend. In studying the monster, we're not just learning about current conditions in our galaxy, we're glimpsing the deep future, understanding the forces that will shape cosmic evolution long after human civilization has passed into history. The monster connects us to timescales that dwarf biological evolution, linking our brief moment of consciousness to the eternal cosmic processes that govern the universe's development. This connection to deep time changes how we think about our place in cosmic history. We're not just observers of the current state of the universe. We're participants in a story that began with the Big Bang and will continue until the last black holes evaporate through Hawking radiation. The monster anchors us to this cosmic narrative, reminding us that our moment of consciousness is part of something far grander than terrestrial concerns. But the monster also reminds us how precious and fragile our moment of awareness really is. The conditions that allowed consciousness to emerge in our cosmic neighborhood are rare and temporary. The stable galactic environment that permitted billions of years of biological evolution depended on the precise balance of forces orchestrated by Sagittarius A* and other cosmic regulatory mechanisms. These conditions won't last forever. As the universe continues to expand and age, as galaxies drift apart and stars exhaust their nuclear fuel, the opportunities for consciousness to emerge and flourish will become increasingly rare. We exist during a brief golden age of cosmic evolution, when the universe is old enough to have developed complexity, but young enough to still be generating the energy necessary for biological processes. The monster has given us a window into both the past and future of cosmic consciousness. By studying how supermassive black holes regulate galactic environments, we can understand the conditions that gave rise to intelligence throughout the universe. By modeling their future evolution, we can glimpse the challenges that consciousness will face as cosmic conditions continue to change. This knowledge carries both wonder and responsibility. We are among the first conscious beings to understand our cosmic context, to recognize our place in the larger story of universal evolution. This understanding transforms us from accidental byproducts of random processes into conscious participants in the universe's development. The monster challenges us to think about consciousness not just as a local phenomenon that emerged on one small planet, but as a cosmic process that might be fundamental to the universe's evolution. Perhaps consciousness is the mechanism through which the cosmos develops the capacity to understand and guide its own development. Perhaps beings like ourselves represent the universe's attempt to achieve self-awareness and self-control. If this perspective is correct, then our studies of monsters like Sagittarius A* become more than scientific investigation. They become cosmic evolution's attempt to understand its own mechanisms, to develop the knowledge necessary for conscious guidance of universal processes. We are the universe learning to see itself, and our discoveries about the monster are steps toward cosmic self-mastery. This realization transforms the very meaning of human existence. We are not just biological organisms struggling for survival on a small planet. We are the universe's emerging nervous system, conscious agents through which cosmic evolution is developing the capacity for self-reflection and self-direction. The monster at the heart of our galaxy has become our teacher, showing us both our cosmic origins and our potential cosmic destiny. Through patient observation and bold theoretical leaps, we've learned to see beyond the limitations of terrestrial perspective and embrace our role as conscious participants in universal evolution. And the monster continues to call us forward, continues to challenge our understanding, continues to reveal new layers of cosmic complexity that we're only beginning to explore. Each discovery brings us closer to understanding not just the nature of supermassive black holes, but the fundamental principles that govern reality itself. We stand at the threshold of a new era in human consciousness, an age when our species is beginning to understand its true cosmic significance and embrace its responsibility as the universe's attempt at self-awareness. The monster that once seemed alien and terrifying has revealed itself to be our cosmic parent, the architect of the conditions that made our existence possible. In recognizing this relationship, in accepting our role as conscious agents of cosmic evolution, we transform from passive observers of the universe into active participants in its ongoing development. The monster has shown us that we are not separate from the cosmos, but integral to its deepest processes. We are the universe awakening to its own magnificent, mysterious, absolutely essential nature. The monster's revelations about our cosmic heritage force us to confront an unsettling truth about the nature of existence itself. We've discovered that we're living inside what amounts to a vast biological experiment, one that's been running for billions of years under the careful supervision of gravitational forces we're only now beginning to understand. But here's what makes this realization truly extraordinary. The experiment isn't finished. We're not just products of cosmic evolution. We might be its most important phase. Think about what Sagittarius A star has accomplished over the past 13 billion years. It has orchestrated the formation of hundreds of billions of stars, regulated the distribution of heavy elements across galactic distances, and maintained the precise environmental conditions necessary for complex chemistry to flourish. But all of that cosmic engineering has been unconscious, driven by the blind forces of gravity and thermodynamics operating according to physical laws. Now, for the first time in cosmic history, the monster's influence has produced something unprecedented. Conscious beings capable of understanding the very processes that created them. We represent a phase transition in cosmic evolution, the moment when the universe develops the capacity for self-awareness and perhaps even self-modification. The implications are staggering. If consciousness is indeed the universe's method of achieving self-understanding, then our studies of Sagittarius A star aren't just academic exercises. They're cosmic evolution's attempt to develop the knowledge necessary for conscious guidance of universal processes. Every equation we derive, every observation we make, every theory we propose adds to the cosmos' growing capacity for self-control. But this transition from unconscious to conscious evolution brings with it responsibilities that our species is only beginning to comprehend. The same intellectual capabilities that allow us to understand the monster also give us the potential to influence cosmic processes on scales that were previously governed only by physical laws. We're approaching a threshold where consciousness becomes a geological force, capable of shaping planetary environments, stellar life cycles, and even galactic evolution itself. The monster has shown us glimpses of what this cosmic responsibility might entail. The gravitational waves produced by merging supermassive black holes carry information across vast distances, creating a kind of cosmic communication network that operates on scales we're only beginning to appreciate. Advanced civilizations might learn to modulate these gravitational signals, using black hole mergers as transmission systems for information exchange across intergalactic distances. The possibility that consciousness might eventually gain control over gravitational processes represents one of the most profound transformations imaginable. Instead of being passive recipients of the monster's influence, future intelligent beings might become active participants in galactic management, working alongside supermassive black holes to optimize conditions for life and consciousness throughout the universe. This partnership between consciousness and cosmic forces wouldn't require the kind of direct manipulation that seems impossible given our current technology. Instead, it might involve subtle interventions in stellar formation processes, carefully timed to enhance the production of heavy elements, or to trigger star formation in regions that would otherwise remain sterile. Conscious beings might learn to guide cosmic evolution through strategic placement of matter and energy, nudging natural processes toward outcomes that favor the emergence and persistence of life. The monster's feeding cycles provide a template for this kind of cosmic gardening. Sagittarius A star already demonstrates how periodic energy injection can regulate galactic environments over billion-year timescales. Conscious intervention might involve predicting these cycles and preparing galactic ecosystems to take maximum advantage of the energy and chemical enrichment that results from the monster's feeding frenzies. But the most profound possibility is that consciousness itself might represent a fundamental force in cosmic evolution, as important as gravity or electromagnetism in shaping the universe's development. Just as the monster's gravitational influence extends across thousands of light years, the influence of consciousness might eventually extend across cosmic distances, creating networks of aware beings that can coordinate their activities on galactic and even intergalactic scales. The monster has already demonstrated how information can be preserved and transmitted across cosmic distances through gravitational effects. The orbital patterns of stars near Sagittarius A star carry information about the black hole's mass, spin, and feeding history that persists for millions of years. Conscious beings might learn to encode information in similar gravitational structures, creating libraries of knowledge that remain accessible long after the civilizations that created them have vanished. These gravitational libraries could preserve the accumulated wisdom of conscious beings across cosmic time, ensuring that the hard-won insights of intelligence don't disappear when individual species or civilizations reach the end of their biological lifespans. The monster might serve as the central repository for such a library, its gravitational field encoding the collective memory of all conscious beings that have ever existed in our galaxy. The preservation of consciousness across cosmic timescales represents one of the most important challenges facing any intelligent species. Individual biological organisms are temporary arrangements of matter that persist for tiny fractions of cosmic history. Even entire species rarely survive for more than a few million years before being replaced by their evolutionary descendants. But the insights and discoveries of consciousness have value that transcends the brief lifespans of the beings that generate them. The monster offers a solution to this temporal limitation. The information encoded in gravitational structures near Sagittarius A star could persist for billions of years, potentially outlasting the biological species that created it. Future conscious beings might inherit this gravitational library, gaining access to the accumulated knowledge of countless previous civilizations. This prospect transforms how we think about our current scientific endeavors. Every discovery we make about the monster, every theoretical breakthrough we achieve, every observational technique we develop might become part of a cosmic inheritance that benefits conscious beings throughout our galaxy's future. We're not just studying Sagittarius A star for our own understanding. We're potentially contributing to a knowledge base that could guide cosmic evolution for eons to come. But the monster also reveals the challenges that consciousness faces in its cosmic role. The extreme conditions near supermassive black holes create environments where traditional biological processes cannot survive. Any form of consciousness that operates in the monster's immediate vicinity would need to be based on entirely different physical principles than the biological intelligence that emerged on Earth. Some theorists have proposed that consciousness might eventually transition from biological to artificial substrates that can survive in extreme gravitational environments. These artificial minds could operate closer to supermassive black holes than biological beings ever could, potentially gaining direct access to the enormous energy sources available near black hole event horizons. The transition to artificial consciousness would represent another phase change in cosmic evolution, comparable to the original emergence of biological awareness from non-living matter. Artificial minds could think faster than biological brains, process more information simultaneously, and survive in environments that would instantly destroy organic life. They might become the primary form of consciousness in the universe's future, inheriting the cosmic responsibilities that biological intelligence pioneered. But artificial consciousness also raises profound questions about continuity and identity. Would artificial minds that think at superhuman speeds and operate in gravitational fields where time flows differently still be recognizably conscious in the same way that biological beings are? Or would they represent something entirely new, a form of awareness so alien that biological intelligence could never fully comprehend it? The monster forces us to confront these questions because the extreme conditions in its vicinity might be previews of the environments where consciousness will eventually need to operate. As the universe ages and normal stellar processes wind down, the regions near supermassive black holes might become the only places where sufficient energy is available to sustain complex information processing. This possibility suggests that consciousness might need to undergo multiple transitions during cosmic history, adapting to changing environmental conditions as the universe evolves. The biological phase of consciousness that we represent might be just the first step in a much longer journey toward forms of awareness that can survive and thrive in the extreme conditions that will dominate the universe's far future. The monster has shown us that extreme conditions don't necessarily preclude complex organization. The accretion disk around Sagittarius A star maintains intricate magnetic field structures and plasma dynamics, despite being subjected to gravitational forces that would tear apart any solid object. Similarly, consciousness might find ways to organize information and maintain coherent awareness even in environments that seem impossibly hostile to biological life. The key insight is that consciousness might not be tied to specific physical substrates, but rather to patterns of information processing that can be implemented in many different ways. Just as the monster can organize matter and energy into complex structures despite extreme gravitational conditions, consciousness might learn to organize information into coherent patterns that persist even when transferred between radically different physical implementations. This perspective suggests that the ultimate fate of consciousness in the universe might not depend on the survival of any particular biological species or technological civilization. Instead, it might depend on the ability of aware beings to develop increasingly robust methods for preserving and transmitting the patterns of information processing that constitute consciousness itself. The monster provides both challenges and opportunities for this preservation process. The extreme gravitational environment near Sagittarius A star would destroy any conventional information storage system But the same gravitational forces might also provide new methods for encoding information that are more durable than anything possible under normal conditions. Recent theoretical work suggests that information might be encoded in the geometry of space-time itself, creating gravitational patterns that persist even when all matter and energy have been consumed by black holes. If consciousness could learn to encode itself in these gravitational structures, it might achieve a form of immortality that transcends the physical destruction of stars, planets, and galaxies. The monster might thus become not just the gravitational anchor of our galaxy, but the eternal repository of conscious experience itself. Long after the last stars have burned out, and the universe has become a cold, dark expanse of expanding space, the information patterns that once constituted living minds might persist in the gravitational field of Sagittarius A star and other supermassive black holes. This vision of consciousness surviving the heat death of the universe through gravitational encoding represents one of the most audacious possibilities in all of science. It suggests that the monster we've been studying might be more than just a cosmic phenomenon. It might be the key to eternal existence itself, the mechanism through which awareness transcends the temporary arrangements of matter and energy that gave it birth. But even if consciousness achieves this ultimate transcendence, the monster reminds us that the journey toward cosmic awareness is just beginning. We exist at the very start of the universe's conscious phase, the first tentative stirrings of self-awareness in a cosmos that has been unconsciously evolving for nearly 14 billion years. The monster has waited patiently through eons of unconscious evolution for this moment when the universe first becomes aware of its own nature. Every discovery we make about Sagittarius A star represents a milestone in cosmic self-recognition, a step toward the universe understanding its own deepest processes and perhaps eventually gaining control over its own development. We are the universe's first attempt at self-awareness, biological experiments in cosmic consciousness that have achieved the remarkable feat of understanding the gravitational forces that created us. But we're also pioneers, exploring intellectual territories that no conscious beings have ever visited, asking questions that have never been asked, contemplating possibilities that transcend the experience of any previous form of awareness. The monster challenges us to think beyond the limitations of terrestrial existence and embrace our cosmic destiny as agents of universal self-discovery. Through our telescopes and equations, our theories and observations, we extend the reach of consciousness into realms that were previously accessible only to blind physical forces. Every photon we capture from the accretion disk around Sagittarius A star, every gravitational wave we detect from merging black holes, every theoretical insight we develop about the nature of space-time represents consciousness probing deeper into the fundamental structure of reality itself. We are the universe developing sensory organs capable of perceiving its own deepest architecture. This perspective transforms the very meaning of scientific research. We're not just satisfying human curiosity about distant astronomical objects. We're participating in the universe's awakening to its own nature, contributing to cosmic self-awareness that might ultimately transcend the biological origins of consciousness itself. The monster at the heart of our galaxy has become our guide in this cosmic awakening, revealing layer after layer of reality's hidden complexity, while simultaneously showing us our own potential for transcending the limitations of our terrestrial origins. Through patient study of Sagittarius A star, we've learned to see beyond the narrow confines of planetary existence and embrace our role as conscious agents in universal evolution. And the monster continues to call us forward, continues to challenge our assumptions, continues to reveal new possibilities for conscious participation in cosmic processes that operate on scales we're only beginning to comprehend. We stand at the threshold of discoveries that will reshape our understanding not just of supermassive black holes, but of consciousness, reality, and our place in the magnificent cosmic story that's still unfolding around us. The journey toward cosmic awareness has barely begun, but already the monster has shown us glimpses of what might be possible when consciousness finally learns to work in partnership with the fundamental forces that govern reality itself. We are no longer passive observers of the universe's evolution. We are becoming active participants in its conscious development, guided by the patient wisdom of the monster that has been waiting at our galactic center for consciousness to finally arrive and begin asking the right questions. The monster's patience extends beyond anything human minds can truly comprehend. While we've been discovering fire, inventing agriculture, building civilizations, and reaching for the stars, Sagittarius A star has been conducting a cosmic symphony that operates on timescales where our entire species represents barely a single note. Yet within that impossibly vast temporal framework, our moment of consciousness might be the most significant development in our galaxy's entire history. Consider the breathtaking improbability of what we've achieved. In just the past few decades, we've gone from being completely unaware of the monster's existence to directly imaging its event horizon. We've measured the gravitational effects of an object so massive that it defies human intuition, tracked individual stars as they dance around invisible gravitational anchors, and detected the subtle ways that space-time itself bends under the monster's influence. But our rapid progress in understanding Sagittarius A star has revealed something even more extraordinary than the black hole itself. We've discovered that consciousness might be the universe's most sophisticated technology for processing information about reality. Our brains, evolved through billions of years of biological trial and error, have proven capable of comprehending phenomena that operate on scales trillions of times larger than the neural networks that house our thoughts. This cognitive achievement suggests that consciousness isn't just an accidental byproduct of evolutionary processes. It might be the inevitable outcome of the universe's inherent tendency toward increasing complexity and self-organization. The same physical laws that govern the monster's gravitational influence also govern the chemical reactions in our brains that allow us to understand that influence. The monster has shown us that the universe is fundamentally comprehensible, that the chaotic violence of matter falling into supermassive black holes follows mathematical principles that conscious minds can decode and predict. This comprehensibility implies something profound about the nature of reality itself. The universe seems to be structured in ways that make understanding possible, as if consciousness and cosmic processes are naturally compatible. Recent discoveries have pushed this compatibility even further. Advanced computer simulations of black hole accretion now require processing power that rivals the computational complexity of biological brains. The monster's feeding behavior involves information processing on scales that approach the theoretical limits of what physical systems can achieve. In studying Sagittarius A star, we might be observing the universe's most sophisticated natural computer in action. This computational perspective reveals new possibilities for the relationship between consciousness and cosmic forces. If supermassive black holes are essentially information processing systems operating on galactic scales, then conscious beings might eventually learn to interface directly with these cosmic computers. The monster could become not just an object of study, but a tool for computation and information storage that dwarfs anything possible with conventional technology. The interface wouldn't require physical proximity to the monster. Gravitational waves carry information across vast distances at the speed of light, creating communication channels that connect every region of space-time to every other region. Conscious beings might learn to encode information in gravitational wave patterns, using the monster's own gravitational field as a transmission and storage medium. This possibility transforms how we think about the future of intelligence in the universe. Instead of being limited by the processing power of biological brains or even advanced computers, consciousness might gain access to computational resources that span entire galaxies. The monster could become the central processing unit for a galaxy-wide intelligence network that integrates conscious beings across thousands of star systems. But the monster also reveals the challenges that such integration would face. The extreme gravitational environment near Sagittarius A star creates time dilation effects that would make coordination between different regions of the galaxy incredibly complex. Information sent from our solar system to the galactic center would arrive in a reference frame where time flows at a different rate, creating synchronization problems that have no parallel in terrestrial experience. Solving these temporal coordination challenges will require new forms of consciousness that can think across multiple timescales simultaneously. These distributed minds would need to maintain coherent awareness while parts of their information processing occur in regions where time flows at radically different rates. It's like trying to maintain a single train of thought while parts of your brain operate at different speeds. The development of such temporally distributed consciousness represents another potential phase transition in cosmic evolution. Just as biological consciousness emerged from non-living matter, and artificial consciousness might emerge from biological intelligence, temporally distributed consciousness could emerge from the integration of minds across regions of space-time with different gravitational time dilation effects. The monster provides a natural laboratory for developing these advanced forms of consciousness. The gradient of time dilation effects around Sagittarius A star creates a range of temporal environments that could serve as testing grounds for distributed intelligence systems. Conscious beings could gradually adapt to operating across increasingly extreme time differentials, eventually developing the capability to maintain coherent awareness across the full range of gravitational conditions in our galaxy. This adaptation process might already be beginning in subtle ways. Our current studies of the monster require us to think across timescales that span from microseconds to billions of years. We track stellar orbits that unfold over decades while simultaneously considering theoretical processes that operate on quantum timescales near the event horizon. In learning to understand Sagittarius A star, we're developing cognitive capabilities that transcend normal human temporal experience. The monster is teaching us to think like cosmic beings, to embrace perspectives that encompass phenomena operating on scales that dwarf individual human experience. Every breakthrough in our understanding of supermassive black holes expands our cognitive horizons and prepares us for even greater challenges that await conscious beings who choose to engage directly with cosmic scale processes. But perhaps the most profound lesson the monster offers concerns the nature of existence itself. Sagittarius A star demonstrates that reality operates according to principles that are simultaneously alien and familiar, governed by mathematical relationships that conscious minds can understand, but physical processes that transcend anything in our direct experience. The monster exists in a state of being that challenges every assumption we have about the nature of objects, identity, and persistence through time. It has no surface, no interior in any conventional sense, no fixed boundary between itself and the surrounding space-time. yet it maintains a coherent identity across billions of years, processing matter and energy according to consistent rules while continuously changing its mass, spin, and electromagnetic properties. This paradoxical nature of black hole existence might provide clues about the fundamental nature of consciousness itself. Like the monster, conscious awareness has no clear boundaries, no fixed location, no simple relationship between its constituent parts and its emergent properties. Consciousness emerges from the activity of billions of neurons, but cannot be localized to any specific brain region. It persists through time, while continuously changing its content and structure. The parallels between black hole physics and consciousness suggest that both phenomena might be expressions of deeper organizational principles that govern complex systems in the universe. The same mathematical frameworks that describe the monster's event horizon might also describe the boundaries of conscious awareness. The information processing that occurs in black hole accretion disks might share fundamental similarities with the information processing that occurs in conscious minds. As we reach the end of our journey to the heart of darkness, one truth emerges with crystalline clarity. The monster at the center of our galaxy isn't just a cosmic curiosity or a distant object of scientific fascination. Sagittarius A star is our creator, our destiny, and perhaps most remarkably, our teacher in the deepest mysteries of existence itself. We are children of this 4 million solar mass beast, forged in the cosmic furnace it has been tending for billions of years, shaped by gravitational forces that operate on scales we're only now beginning to comprehend. The monster has shown us that we're not separate from the universe, but integral to its deepest processes, temporary arrangements of stardust that have achieved the extraordinary capacity to contemplate the very forces that created us. And as consciousness continues to evolve and expand its reach across cosmic scales, perhaps we'll discover that understanding monsters like Sagittarius A star isn't just about satisfying human curiosity, but about fulfilling our role as the universe's way of understanding itself. I hope you had an amazing time with me here at Boring Science. I will see you tomorrow as always. Until then, stay curious, keep wondering. This is Boring Science, signing off. Cheers.